Good morning.
Good morning, sir.
Yes. So we are all meeting today to understand the basics of mechanics. I will call it as mechanics part 1 because there is going to be part 2, part 3 and so on and so forth. So in today's session, we will learn the following. Please come. As you can see on the board, if you cannot see, you tell me to move around, right? Feel free to ask questions. Come and sit here. Come here. Okay. See, the topics that are going to discuss is all listed here. All right. And as you can see, the concept of motion, instants of time, and time interval. Because I find that from my experience, some students, they confuse these two. Then frame of reference, position vectors, path of travel, then comes distance, average speed, instantaneous speed, unit vector, velocity vector, displacement vector, triangle law of vector addition, parallelogram law of vector addition. We are going to discuss these topics today. Feel free to ask any questions and just enjoy learning. Okay, as you know, the best way to learn, especially physics, is to experiment and learn. Okay, you can see the laws in physics, most of them have evolved by the process of experiments, and it is the best way of understanding the physical phenomena. So I'm going to show you some experiments here, and you've got to keenly observe, right? Involve yourself, and then you can definitely learn, right? If you have issues, please bring it to the fore. We will discuss. All right, friends. So here we go. So this is our first slide. So, you can see a plain board here. It's fairly smooth. And then you can see an object here. Please find an object here. This is basically a marble. Okay. But for all practical purpose, you can consider that to be a particle, right? With certain mass. And then, of course, this is fairly smooth board. And most important thing is you should see that there is a stopwatch here, okay, which is going to show in seconds and milliseconds. 5.842 is 5 seconds and 842 milliseconds. This is important for our motion. You see, it is the positions, the body. Please come here. The positions the body occupy, that is when it is in motion, and you should also keep an eye on the timer. At what time, at what position it is, right? So all these things are involved. Now, anyway, to begin with, all of you enjoy this motion, right? Okay, so you saw the object in motion, correct? Right. Now we will discuss various parameters involved with motion, and in order to understand motion, we need vectors as tools. So I will introduce the vectors also. Okay, so this forms the fundamentals. All right. So I hope all of you observed the motion of this, and also as it was moving, I hope you have observed the timer. Okay. See, right now it is in this position at this time. Okay, so the timer is moving. This is important. Whenever you want to conceive motion, you should know that it's all happening with respect to time. The change of position is happening with respect to time. Okay, so we will understand this concept of position itself first, and then we will move on to the exact definition of motion. All right. So now what you see on the screen is the same board, okay? And again I will show you that the object has moved, right? So again you see I have marked 3 points, 3 arbitrary points, and then you also see that, you also notice that I have drawn 2 lines here. This is I call it as the origin for the reference point, and then this is the y-axis and this is the x-axis. And then, well, you know, I am locating the points. I am locating the position occupied by this object at different instants of time. So this is location number 1, which I call it as P1. P1 5.842 corresponds to the time. So it is at this position at this time. It is at this position at this time. It is at this position at this time. And I am precisely locating the positions by drawing these lines with arrowhead, which is called as position vectors. It is called as position vectors. Now just follow me, you will understand it better. So here you see, the body is said to be in motion since it occupies different positions at different instants of time with respect to a reference point. The body or the particle is said to be in motion since it occupies different positions. Right. Now you please understand, as the body is traveling, okay, it is, what is it doing? These are all the points in space. You see, what is space? Collection of points. The body is occupying all these, going through all these points as it is moving. Now these points, okay, if you reference these points with respect to this reference point, then these points shall be called as positions. So now to make it better, this body is occupying different positions at different instants of time with respect to a reference point. I hope you got it clear. And I am using the concept of position vector. Now you can see here that I am naming the position vector as R3 bar, R2 bar, R1 bar. Now that bar here means it is a vector, and vector means it contains two informations. The information about how, in this case, the information how far it is from this reference. See, this body is at this position, how far it is from this position. That is one information. Okay, but now try to understand. Supposing I say from here to here it is 2 meters. Okay, now you can see that from here to here also it is 2 meters. So if I simply say the body is at 2 meters from O, then it can be anywhere. It can be here, here, here. So therefore we need additional information. What is that additional information? This angle. You can see with respect to the reference, this is precisely making an angle comma. Right? Similarly, at this position, it is precisely making an angle beta. So now with the two information, that is, it is at this distance from this point, and it is making an angle comma with respect to the reference. With these two information, I can precisely locate the position, and therefore this line with the arrowhead is called as position vector since it is locating the position of the body. Have I made myself clear? Now you see coordinate axis. So this x-axis, y-axis. Now I am using only two planar diagram. So I am just defining x and y-axis. So this x and y-axis are the coordinate axis. Okay, and along with the timer, the coordinate axis with the timer constitutes the frame of reference. So frame of reference, usually students say, well, it's only xy or xyz axis. No, you have to also include the timer in physics. See, now I'll tell you students, while you learn mathematics, you know, the same terms and terminologies are used, but their meaning is slightly different than what you learn in physics. In physics, we are using mathematics to understand physics. So it has its own way of, understanding things. So just be aware about it. So what is the coordinate frame of reference in physics? Please answer fast. Loud.
Locate the position.
What is coordinate frame of reference? What is frame of reference in physics? What is frame of reference? Just now I explained. the coordinate axis. See, this xy is the coordinate axis. Okay, O is the origin, and plus the timer constitutes the coordinate frame of reference or the frame of reference. Got it? So, what is frame of reference in physics?
The coordinate axis with respect to time.
No, not with respect to time, and the timer. Understand? See, please, this is what See, I too learned physics and I learned the wrong way. And I know, most of you do the same mistake as I did long ago. So don't do that. See, now coordinate axis plus the timer becomes the frame of reference in physics. Clear? So this is a total thing. Because usually, see, whenever we say frame of reference means we only consider xy. Correct? In mathematics, we should do that only. But here, for us, we also have to use time, because the body is moving. As the body is moving, you can see. Now observe this very carefully. As the body is moving, the timer is also moving. That is, the time is increasing. Understand? So there is time and space. The body is occupying different points in space, and the timer is advancing. The time is advancing. When these two combinations, that gives rise to the concept of motion. So motion cannot be understood just because it is occupying different positions, right? So it has to occupy different positions at different instants of time with respect to a reference frame. Then only the motion is caused. And all these are very important to understand the physics. And at this stage, you please appreciate what I have told, and these are all very, very precise and concise statements. Clear? Any confusion? Hello? Now I want you to speak very loudly and clearly and attentively. Alright? Your time and my time will be saved. Now, the positions of the body at different instants of time with respect to the reference frame is shown by straight lines. These are the straight lines. Now, these lines are called position vectors. Which lines?
Straight line.
There are so many straight lines. So the straight lines turn from O to positions. Okay, right. And their magnitudes. Magnitudes means, now what is the size of the vector? Now, in this case, size means the length of this line. The length of this line from here to here is the magnitude of this line. Okay? Then corresponding to the lines, and the directions are the angles made by these arrows with respect to the reference. You can see this is the reference point, and these are the angles alpha, beta, gamma. Okay? Right. The physical quantity gets completely specified. Which physical quantity? The position of the body. The position of the body gets completely specified since its magnitude and directions are specified, and hence position vector. This arrow now becomes a position vector. Clear? So two informations are embedded in that. Any question? Okay. Now come to the next frame. Now once again, observe the motion. Now when I say observe, you should not see, right? Okay, what is your observation?
So time between.
Loud, whatever you have observed, you tell.
The time between the positions of the object is there is a equal constant time interval.
Are you sure it is constant time interval? On what basis are you telling? No, don't imagine anything. You observe and tell. I am not asking any quiz question to all of you. There is an experiment going on. You observe that experiment and you tell what you have observed. I am not asking you any answers. What you have observed, you tell. Now once again observe. What did you observe?
The object is now occupying a different points at a different instance of time.
Not points, positions. It is occupying different positions at different instance of time. Okay, right. And what else did you see here? Now, what you see here is, the body as it is traveling is moving along a locus of points. I have joined all these locus of points and I have found a line. Can you see that? Hello?
Yes.
So now here you see, observe the motion of a particle. It travels through a locus of points, which when joined together is called forms a line, and that line is called path. That line is called path. See students, see what, you should not take things for granted. What is path? What is motion? Right? So these terms appear to be very trivial, but they are very concentrated. They have to be understood properly. Okay, so now what is a path? Okay, it can be a question asked in examinations, but that apart, you see, you have to understand these aspects very clearly, because if I ask you what is a path, you must be able to define what is a path. Okay, and now you can very clearly see that, these are the points along which the body has moved, and it forms a locus of points. They are continuous points, and then they are all joined. Then you get the concept of line, and this line is called the path. Okay, right. So now, with respect to the reference, these points any point on this path becomes the position of the path. Now I am not showing the coordinate axis here because I had shown this as the coordinate axis in the previous slide. Now I can choose any point in the space as the reference plane. Locate the positions of the points. But of course, the position vectors will be different. Did you get it, or did I confuse you? Louder.
So I got it.
You got it. What about you? You got confused. Okay. Now you see, I can choose this point as the reference. Right? I am free to choose. Then this becomes the position. Understood?
Yes.
These all become position. And they are different. So the concept is, you must choose, right? Or you must choose, not fix a point, you must choose a point of reference, and with respect to that, you can locate the points. That's the whole idea. Is that clear? Right. So that trace the path. Now you see, you have traced the path traveled by the body, and well, let me. So what is that blue line you are seeing? That is the path traveled by the body. That's the path traveled by the body. Okay? Now on this path in which the body has traveled, I am choosing two arbitrary points, A and B. So the body had occupied this position A and B at these times. Okay? Now you see, I am going to ask you, you have got to measure the length of this path from A to B. How will you measure the length of the path from A to B? Come on, if I ask you to come to the board and measure the length of the path, how will you do that?
So there are two ways.
Louder.
So there are two ways to measure that.
You are two what? Two, what did he say? Two ways.
Yes.
Loudly, man. Why are you speaking so slowly? I'm able to hear. See, I want it to be recorded here. Come on, speak loudly.
Yes, so one is like a straight line, which is the vector between. Yes.
See, I am asking you to measure. Did you understand the concept of path?
Yes.
I want you to measure the path from A to B. The length of the path from A to B. How will you go about doing it?
So like by drawing a straight line between all the points where the object is at different in.
That is, you are going to draw a straight line from here to here, from here to here, from here to here, from here to here.
Yes.
Okay, you are going to draw straight lines, and then
measure those two.
you measure the straight lines. How will you measure the straight lines?
There are coordinates.
Okay, so you will measure the straight lines using some scale or something. Okay. Okay, that is method number one. What is the other method?
So like.
Okay, Rushil, tell loud.
So you can take a straight line. You can take a thread.
You can take a thread.
And measure from point A to point B.
How will you take a thread and measure from A to B?
So we should keep the thread.
You should keep the thread along the path. You tell, see, you are sitting in physics class. You cannot assume, oh, let the teacher knows what I am thinking. If you take a thread, I don't know what are you going to do. Say, you are going to place the thread all along this line. And then you are going to take the thread and use a meter scale and measure its length. So what did you measure by this process?
The length of the path.
The length of the path traveled by the body from A to B. Got it? And this measurement gives you what? It gives you the concept of distance. The distance from A to B is the length of the path traveled by the body. Have I made myself clear? Huh? Huh. Now, there is a confusion between the term distance. In mathematics, the term distance is different. In physics, the term distance is different. I'll make it clear to you. Okay? I'll make it clear to you in the next slide. All right. So before I make that aspect clear, I would like to introduce one more aspect here. Now we are all familiar with the terms like speed, right? Now let's understand this concept better, right? So what is speed?
Speed is the distance traveled in unit time.
Now, for example, now it is the distance traveled in unit time. That's precisely what you are telling. Now, can you elaborate and explain what you mean by that?
It's the magnitude of distance.
When do you use see, there should be something called as qualitative description and quantitative description. That is physics. If you say at unit, you are measuring it. So, what is the speed in qualitative terms?
It's the in a given interval of time, it's the magnitude of distance traveled.
In a given interval of time, is the magnitude of distance traveled. Okay. Again, you are measuring. When will you use this concept of speed?
When an object is in motion and to find
what?
To find how much distance will it cover.
Okay, again you are measuring. Right. Now let me put it like this. Say you are traveling in a car. What are you going to do when you are traveling in a car? What are you going to do when you are traveling? Assume that you are traveling in a car, and what are you going to do? You can do so many things. You can listen to music, you can speak, you can sleep, you can do whatever you want, unless you are driving. Okay. Now, at times, you would like to know, like, how fast my vehicle is moving, or how slow my vehicle is moving, relative to something. See, supposing there is another car beside you, so, it's also traveling, and then you want to know how fast my car is moving with respect to this. Or, some objects like trees and stones on the road, and how fast your car is moving or how slow it is. So, when you want to understand like how fast or how slow my vehicle is moving, then you are going to make use of the concept of speed. That is first part. And the second part is you got to measure the speed. Understand? So please understand these two things. Now, you find two people, oh, he is taller than him, she is taller than him, vagara, the comparison starts. So first of all, you will identify that somebody is taller than somebody. Then the next question is, how much are they taller? Then the measurement will come into picture. Okay? So therefore, speed, you will use the concept of speed when you want to know how fast or how slow a body is in motion. Point number one. And next is, how will you measure this speed? Okay, there are many ways of measuring speeds. There are many different types of speeds are there. So one of the things is average speed, right? Now you see what you do here to measure the average speed. So it is traveling, it is going to travel along this path. Observe this once again. Now, first and foremost thing, you see that during the travel, the speed at different points are different. See, it was moving at some speed here, it was moving at some speed. It may be or may not be moving. It may be moving at different speed at different instants of time. Did you capture that? Hello?
Yes, sir.
Now, overall what I want is, from this point A to this point B, it has traveled. Okay. Now, I would like to know something like a statistical average. That is, what I do now here is, I will measure the distance from A to B along this path, and I will also measure the instant of time here and instant of time here, which is TB and TA, and I subtract TA from TB. I will get what? If I subtract the instant of time here and instant of time here, what will I get?
The time interval.
The time interval or the duration of travel. Okay. Now using these two informations, which information? The distance traveled and the time duration for which it has traveled. I will now do this operation. What is the operation? The total distance traveled between 2 points divided by the time taken to travel the above distance. Then I will get a number. That number I will call it as what?
Average speed.
Average speed. Right? Average speed. Okay. Now let's have some more understanding of this average speed. So you see here the particle may be moving at different speeds at different instance of time. The particle may be moving at different speeds at different instance of time. Right? So the speed is more, less, वगैरह, but it will go from here to here at the same time. Now imagine the body is moving at, when it is at position A, the time is 6.142, and when it is at position B, the time is again 8.22. But now if I can control the motion, what did I say? If I can control the motion, I will make the body to move along this path with this speed. Which speed? V. Constant speed V. Understand? I will not allow that to change. If I make this body to move with this speed V from this point to this point, will the duration of time increase or decrease? If I make the body to move with this speed, which speed? Average speed, from A to B, will the duration increase or decrease? Okay, now look at it will neither increase nor decrease. It will neither increase nor decrease. Now look at this. Understood? So the concept of average speed is, if you make the body to move with the calculated average speed from A to B, then it will take the same time and the same path, but it will travel with that constant speed. Understand? So therefore, that is the idea of average speed. Say from Hubli to Dharwad, you would have traveled 20 kilometers, and say you would have traveled 20 kilometers in say 20 minutes. Right? Okay. That is one way. But when you are traveling from Hubli to Dharwad, you would have, your car speed would have gone to 100 km per hour at some point, or then because of a traffic signal it would have stopped, or because of a buffalo it would have stopped, or because of a passing vehicle you would have slowed down. Can you imagine all this? So you would have taken 20 minutes to reach after this process. Now imagine the road was completely clear, no traffic signals, no bullocks, and then you go with some set speed and still reach the destination Dharwad in 20 minutes. So with what speed should you drive to reach 20 meters? With what speed you should drive? That becomes the average speed. That becomes the average speed. Now I didn't want the number. I wanted you to understand this concept. See, you are always busy calculating and getting the answers. Physics is not about calculation and answers. Understand? That's what your mind is tuned to. So the moment the teacher asks you a question, you have to start calculating and get the answer. No. Now understanding is different. That is different. When asking you to calculate, you calculate. Now the concept is, if I drive my vehicle with some speed throughout from A to B, from Hubli to Dharwad, okay, I will still reach the destination in 20 minutes. I will still cover the same distance, but with uniform speed. That speed is called average speed. Did you get it? Yes. Hello? See, you should understand the essence, the significance, the use of that concept called average speed. That is important. Not simply calculation. It is not simply a calculation. It is an extremely important concept. But it has to be understood like this. Alright. So you measure that speed, that distance. I will give a new name, SAB. Means S is not speed. S is the term used for distance. Distance from A to B. You can use any nomenclature you want. So you will calculate and write here. That is, you will actually take a thread, put it here and measure this, and with the timer you will measure TB minus TA, and then you will divide, you will get the average speed. Correct? So this is precisely how you have to determine the average speed. Okay. Any questions here?
Yes.
Sure. Right. Now here I am introducing one more concept here. Okay, so here you see, now this you have to understand very carefully. Please read what is written here first. Aram sir. You can sit here. Can you see? Right. Please read. And read it very carefully. Okay, if you are finished reading, you tell me. See here also, the body has traveled in the same path. Now in the previous slide, this position A was here, this position, I had marked this position as B. Now I am marking one more position here, B. But this position B is very close to point A. I can't show that closeness. See, I should show this point here, where here, at this point. That means almost touching, but not touching. What did I say?
Almost touching but not touching.
That is very close. So if I move this point B very close to A, then the distance from A to B is, what is the distance from A to B?
Some distance, it's almost nil.
And almost nil, almost equal to 0. Then what is the time of travel from A to B?
It's in milliseconds.
It is very, very small. See, now I don't want you to, I don't want always measurements to happen. Right? Now let's understand the concept. So if the point B comes close to A, right, then the distance from A to B is very, very small, almost equal to 0, but not equal to 0. And automatically the time of travel from A to B will also be negligibly small, almost equal to 0, but not equal to 0. Did you get that?
Yes, sir.
Now this is how you have got to understand this. Okay, now there's the purpose of doing this. There's the purpose of doing this. So when you do like that, okay, and if you take the ratio of SAB by TAB, what do you get? Ratio, only now concentrate on this. SAB by TAB, what do you get?
The average speed.
Louder.
Average speed.
So ratio here, if you take this ratio, you are going to get the average speed. Got it?
Yes, sir.
Yes, sir.
Now, this average speed under limiting conditions. What are the limiting conditions? TAB tends to 0. Okay, then a new concept is defined. What is the new concept? The instantaneous speed at A. We define a new concept called instantaneous speed at A. Right? Now what is instantaneous speed? Come on, try to define.
The speed at a time interval which is almost negligible.
Okay, that's how you make it. Alright, anybody else? What is instantaneous speed? Loud. Whatever you feel you tell, don't worry. Don't worry if you make a mistake. Online students, okay, there are students online and there are students offline here. Yes. Online students, you can also answer. What is instantaneous speed? Instantaneous means, see the word instantaneous means speed at a given instant of time. At a particular instant of time becomes the instantaneous speed. Now you see this question here. The body is at position A. The body is at position A. It is at this position, right? And at this position at this time. So I want to know the speed at this position at this time. See, the body is in motion. It is not that the body is has stopped moving. Understand? It is not that it has started moving from that point. Can you appreciate that? Hello? See, did you see that when it crossed A, it was still in motion. At that, when it was still in motion, what is the speed? I want to know. When it's still in motion at point A, at that instant, what is the speed? I want to know. Got it? Now tell me, how can you find the speed at position A when it is in motion? So for that, we are using this technique. What is the technique? See, now the body is at point A, and the next thing is it will move to point B. The next instant, it is going to move to point B. Understand? Right. So what I do is, I will take this small distance and divide it by the time. So it is almost that A and B are the same points, but not same, but they are almost same. Got it? So under this consideration, the speed at A and speed at B are almost same. Hello, what did I say?
Speed at A and speed at B are almost same.
Or in other words, you see, between A and B, there is hardly any change in speed. Between A and B, there is hardly any change in speed because they are very close. So for all practical purpose, the speed in that interval of time is the same. And for all practical purpose, we will call it as the instantaneous speed. Did you get it? See, the speed of the particle at this point and the speed of the particle at the immediate next point. It is almost same. So for all practical purpose, the speed between A to B is almost constant. It is same as the speed at A. In conditions, the average speed becomes instantaneous speed under limiting conditions. Got it? Mathematically. But physically, it is, in qualitative terms, it is the speed at that particular instant of time. Okay, fine? Hello?
Yes, sir.
So this is how you have got to understand. I suppose I made some things clear to you. Right? Some misconceptions are clear, I suppose. I don't know how much I am able to make it better to all of you. Alright. So now, here we are going to the next concept. Now try to understand this concept. If you have understood the previous concepts, you will understand these concepts. So now here very carefully, you read whatever. In general, V can be different at different instants of time. The speed can be different at different instants of time. Mathematically, we are going to write it as V of t. So V of t might be a new term to you. So you should understand that the speed V is a function of time. That means it depends upon time. At different instants, the speeds are different. That is what it means. Means V is a function of time. The body, and now I can give some values of t. So at position A, the value of t is Ta. So V of Ta, and it is moving towards B. That's precisely what is. If the direction from position A towards B can be specified by an arrow from A towards B, whose length is equal to the unit physical quantity is called velocity. Now what I do here? See, here you can see the green arrow here below the yellow arrow. Hello? Can you see the green arrow below this yellow arrow?
Yes.
Yeah. So this green arrow below the arrow. Now you see the distance is measured in some units. It can be centimeters, it can be meters, etc. So now assume that I am measuring the distance in meters. Assume. So what I have done from this point to this point, and I have put the arrow here. Can you see?
Yes, sir.
Yes.
Now this line, this green line here, is passing through B. That is important. So now this green line E with the arrowhead, I will call it by a name called unit vector, because the size of that vector is 1 unit, and I am giving a name like this, R cap EB. Matlab unit vector from A towards B, unit vector from A towards B, and what it means is it is a vector whose magnitude is unit and it is from A to B. Did you get it? You will understand this. See, now understand that there is a concept called unit vector. Did you get that? Hello? Any questions? Any questions? Right. And then what I have done, why I have done that? Why I have written that? There is a purpose. Now that you see, I am going to define a concept called velocity. You know what is speed. Now I am going to define a concept called velocity. You know what is instantaneous speed, right? Now similarly, I will define a term called instantaneous velocity. Now you see, at times it becomes necessary to specify the speed and the direction. At times it becomes necessary to specify the speed of the object and the direction in which it is traveling. See, my car is moving at 10 kilometers per hour. That is speed, instantaneous speed. My car is moving at 10 kilometers per hour towards north, towards Rushil's house, towards Adisi's house, right? So when I specify the speed and also the direction of its travel, then a new concept called velocity will be introduced, comes to the fore. A new concept called velocity comes to the fore. So what is velocity? It is written there. A velocity is a quantity that specifies both the speed of the body and the direction of motion. The speed specified along with the direction becomes velocity. Got it? Now, that term velocity contains two informations. What are the two informations?
Speed of the body.
Speed becomes the magnitude, direction becomes the direction. So, it is a vector. Do you appreciate it? Speed is a scalar quantity because you have to only specify the magnitude. Velocity becomes a vector quantity. Why? You have to specify both the speed and direction. That is one thing. I hope all of us understood that. But now the next task is I have to represent it. I have to measure it. Okay? So for that, I will be needing something like this for the representation. You see here, VA bar. See, I am using the term VA bar. So VA bar means, see, I can use any, I can use any symbol. So V bar, bar means it's a vector. A means it is the velocity at point A. You can give your name also for that. But better give some names which are more meaningful. So VA bar stands for the velocity at A. Now there are two things involved. What is this? The magnitude or the speed and the direction. So V of the A gives you the speed multiplied by what? R cap AB. So R cap AB specifies the direction in terms of unit vector. So this combination gives you the velocity at point A. Is that clear?
Yes.
You have any confusion? You ask.
So what is the difference between unit vector and position vector?
Good question. Right. So I showed you the position vectors in the previous graph.
Yes.
So what were the position vectors doing?
So it was showing
Loud.
distance from the origin.
It was?
Showing the distance from the origin of coordinates to that point.
So it was showing the distance from origin. That is position vector. What is position vector?
So, to showing the position of the object with the reference.
What are the position vector doing?
So, a position of an object on a plane with a reference point.
No, all the three of you are wrong. Anybody else would like to give me the right answer? See, what is the position vector? Is it only the distance from the origin to this? Mr. Srish, is it the distance only? The position vector is only giving you the distance? What else it is giving?
Angle between.
It is also showing you the direction, no? Isn't it? Then why you didn't say so? If it was only specifying the distance, then it becomes a scalar. And I told you also, see, this position is also at the same distance. Understand? So if you want to uniquely spot where the body is, then you have to specify both its magnitude and direction. That is the purpose of position vector. Hello, are you with me? So its purpose is that, its purpose is sorting. Okay. Now, here you see, I want to develop this mathematical concept of velocity. So I want to have a way of telling, look, the speed of the body at this instant is so and so, and its direction is so and so. So what is the direction of the speed at this point? What is the direction of the speed at this point?
So it's towards B.
Towards B, correct? So I want to bring that out. I want to bring that that thought in me outside. So there should be some way of writing it that it is towards B. But simple words is not sufficient, because in mathematics you should use the mathematical symbols which has got precise meaning. So I create a new symbol. I create a new symbol. What is I define a new symbol. How do I define a new symbol? I will draw a straight line from A going towards B, and I will ensure that the length of this line is unit. Okay, and I define it as unit vector R cap AB. Got it? So R cap AB, what is R cap AB?
It's a unit vector defining like a line is moving from A to
It is a unit vector whose magnitude is 1 and direction as specified. As specified means, supposing now the body was moving at this point it was here, next point supposing it was here. Then the body would be moving like this. Hello? Then how do you, supposing this point is C, then how do you specify that the body is moving from A towards C? Loud.
like R cap AC.
So I would have defined a unit vector in this direction. Correct? And then, but the speed is same. So I would have specified this quantity, and I would have re-specified that quantity as R cap AC. So that gives you the information that the body is moving from A towards C. This gives you information that the body is moving from A towards B. Got it?
Yes.
Now can you tell me the difference between position vector and unit vector?
So in a position vector, a definite direction is given where the
Position vector.
yes.
What is position vector? What did the position vector do? What did it do, man? I showed you that.
It defined the distance and the direction.
It didn't define. It didn't define. Define it as, see, will the position vector define the distance? What is distance? Length of the path traveled? No. Hello. It didn't define, man. It is measuring. Position vector gives you information about the distance, how far it is from the body, how far, not the distance, how far it is from the reference point and in what direction is it. That is the purpose of position vector. Got it? What is the function of unit vector here? It is just a vector. It is just a line whose magnitude is unity and the direction in whichever direction you want. Say, supposing I define this as unit vector. So this is a unit vector towards you. This is another unit vector towards him, another unit vector towards him, another unit vector towards her. That's it. That's all this unit vector is. The job, see, this is a unit vector. Now, if you use this unit vector like this, then in this context, it specifies the velocity. Its uses are multitude. There are thousands of uses of this. Thousands, more than lakhs of uses of this. So in different context, I will use it in different manner. See, there is knife in your home. What are the uses of that? What all you have used it? Apart from cutting vegetables, you have done so many things else also with that knife. So there can be many uses of some things. Understand? It doesn't mean it is this. So like that, this one will have multitude uses. Here it is having the usage of this is to define the velocity vector. Got it? It's simply a line with whose magnitude is 1 and direction as specified. That's it. Position vector will locate the position of the body, and that means it is going to tell you how far it is and in what direction it is. Here it is only telling you, look, this is a straight line drawn from this point to this point, from this point towards this point, and its magnitude is 1. That's it. That's the difference between position vector and the unit vector. Still, did I confuse you, or are you convinced? Sure. Hello. What about you? What about you? Okay. So that is it. So I want to create this mathematical model. So I created this concept of unit vector. Otherwise, I would have written there. Okay. The speed VTA in towards B. Towards B. Okay. Like that, I just cannot write in mathematics because you're going to do so many operations with this. You will understand that later on. At this stage, you just understand that I am using this notation r cap AB to define the velocity at point A. Got it? So r cap AB is a unit vector from A towards B, magnitude and direction. Okay. Now I am now defining this. See, this bar is coming. V bar TA, V bar TA, V bar ITA, all are same. I am using one more suffix there. Why? Because I want to say it is instantaneous velocity. If I don't specify that, then it becomes average velocity, which I will define later. So limit TAB tends to 0, S bar AB. S bar AB becomes what? What is S bar AB? Hello?
Distance.
What is S bar AB? Yes, AB is distance. What is S bar AB?
Distance in the specified direction.
Yes, a distance is specified. Very good. Excellent. See, this is how you have to show that you have understanding. Allow me to correct if you are wrong. So it shows that yes, AB is the distance, and since it is very small, S bar AB becomes a vector. I will call it as displacement vector. I will define it in the next slide. Divided by TA gives you the velocity. So VTA bar r cap gives you the instantaneous velocity. Is it clear?
Yes.
Well, the body is in motion. Got it? All these are motion. Now read what I have written on top very carefully. Observe that the particle is in motion. In mathematics, the distance between 2 points is the length of the line joining the 2 points. So, the distance between you and you. In mathematics, you just have to take a tape and measure the distance. Understood? Yes. But in physics, distance means what? The body has traveled. Now, if I ask you what is the distance between these 2 points, in mathematics class, you have to just take a tape and measure this. In physics, if I tell you what is the distance between these 2 points, then it means I am asking you, if a body has traveled from this point to this point, what is the distance? Now, the counter question that you have to ask is, sir, from this point to this point, which path has the body taken? So, if it has taken this path, then the length of this path becomes the distance between these 2 points. If the body has traveled like this, then this itself becomes the distance. Got it? Hello?
Yes, sir.
So now, this confusion should not be there for you. That is, distance is so and so. In mathematics, teacher tells you distance, then this is it. Or even in physics, what is the distance? See, unless you are talking about motion. If anywhere they say distance, that means it is you just have to take a tape and measure. Unless otherwise stated. But if you are talking about motion and the distance, then you should also specify the path traveled. Then you will get a measure of the distance. Have I made myself clear?
Yes, sir.
Right. Now, in this case, you see, I have chosen 2 more arbitrary points, C and D. And in the previous class, S bar AB, you can see this vector. Hello?
Yes.
So this is a vector, S bar AB. And Rushil told the right answer. Good. Now I have chosen another 2 points, C and D. Alright? And I have drawn a line from C to D and I put an arrow. Arrow line means it is a vector. And I have given the name to this as S bar CD. So what is S bar CD? I have written here, man. It is called the displacement vector. Now understand this very carefully. Understand this very carefully. See, the body has traveled from C to D, not like this. It has traveled along this path. Hello, are you clear? Now I am defining a very, very important concept here called as displacement vector. What it means? Similar to the position vector, with additional condition that the body must have traveled from A to B along any arbitrary path AB may or may not be close. See here, it has, so now, okay, let me, I am defining it here with AB, that is, it has traveled from A to B like this. So it could have traveled from A to B from some other point also, from some other direction also. No, I will not take this, see, what this statement, what this sentence is telling you is, okay, what that statement is telling you is that the body could have traveled from this point to this point like this also, okay, or like this also. The body could have traveled like this. Hello?
Yes, sir.
Irrespective of the path chosen, the displacement of the body is S bar AB. Now, in this case, see here the body has actually traveled along this path, and I will call this as path 1. Okay. Now, if the body has traveled along this path, or if the body had traveled along this path, right? So still the displacement of the body from this point to this point is still S bar CD. Now let me explain this a bit more. Okay. So here you see, I would like to know the position of the body at D with respect to C. What did I say? I would like to know the position of the body when it is at D with respect to C. That is one of the requirements. I would like to know the position of the body at D with respect to C. Okay? Then, what should I do? What should I do? What should I do?
So you have to draw a straight line from C to D.
Arey, was so nice.
And with that line.
That's it. So here you have to draw a position vector from C to D. And position vector I have already defined. And that position vector in this context becomes displacement vector. So therefore, the displacement vector is the position vector, okay, with an additional condition that the body must have traveled. See now what is the position of Rushil with respect to me? So I just have to draw a line from here to Rushil, put an arrowhead and say this is the position vector which is defining Rushil. Okay, then what is the values of this position vector? I will measure this straight line distance. See, for defining position vector, I don't need the body to travel. So position vector can be defined whether the body has traveled or not traveled. But the displacement vector will be defined using the concept of position vector, but the condition is the body must have traveled. Is that clear?
Yes.
Yes.
Hello? So that is precisely what I have explained. So irrespective of the path chosen, the displacement of the body, the displacement of the body is C, irrespective of the path chosen. Is that clear?
Yes, sir.
Now what is the displacement from this fan to that tube light? There is a fan here and there is a tube light here. What is the displacement vector?
So it's some distance.
No, then you didn't understand. What it means is, if a body has traveled such that it has passed through the fan and then traveled by some other path and then it has touched the tube light. Assume that a mosquito is traveling in this room. It was on the fan and now it is traveling and then it has reached this tube light. So what is the displacement of the mosquito? Draw a straight line from fan to tube light, measure its length, and you take some reference direction. You can take this chajja as the reference line and measure its angle. That gives you the displacement of the mosquito from fan towards tube light. Is that clear?
Yes, sir.
Now another mosquito travels from the tube light. It goes there and here and then comes here. What is the displacement of that mosquito? Same. Understood? Now something you have understood. Thank you. Clear?
Yes.
So displacement is a concept that you have to define. See students, at this stage, you will wonder, what is all this nonsense? Distance is sufficient, speed is sufficient. Why all the hell? But you will soon understand that all these terms are very, very, very important terms. You will have to learn a lot more physics. See, for example, one missile is left from one country, another country leaves its counter missile, and they both have to hit it. But now you see the space. A giant plane carrying 800 passengers and tons of luggage. So huge. If you got to the airport and you have seen. On the skies, it looks like a small part. Small, very small particle. Correct? Now, a missile is left from one country. It is before it comes down and hits the other country. You have to hit it. So another missile has to go and pinpointly hit it at that point. Now try doing it. You and you take 100 stones. You stand there. You throw a stone. Before it hits you, you have to throw another stone and hit it in the air only. Try doing it. Okay? It's so difficult. Right? Now, we are able to launch counter missiles and hit the enemy missiles. So here you see, when you calculate, when you involve the mathematical calculations, this displacement, velocity, all those things will be useful. If you use these things only, you can calculate and hit the other missile. So I will teach you all that. So to understand that theory, you have to understand these concepts at this stage. Correct? Hello?
Yes, sir.
Now, so here I'll teach you two more things. Triangle of vectors in this. Quite simple to understand. Now here you see, students. There is a displacement vector from C to D that you have understood. Now the body has travelled through C and reached E. The body has travelled from C and reached E. So what is the displacement? CE bar or SCE bar. And from E it has travelled to D along the path. What is the displacement vector?
ED bar.
ED bar or SED. ED bar is the vector. Okay, and that ED bar here signifies that displacement. Now, if I ask you what is the total displacement, the total displacement will be CD bar. So now you see, CD bar is a consequence of two displacements, CE bar and ED bar. Got it?
Yes.
Now I have to give a mathematical formulation for that. So I am going to write it as S bar CD is equal to S bar CE plus S bar ED. I am going to write it like this. So does it make sense? Is it right?
Yes.
See, yeah, CE might be 10 units, ED might be 10 units, CD has to be how many units? Look at the diagram and tell me.
So less than 20.
Less than 20, correct? It should be less than 20. But I am writing here S bar CD plus S bar CE is equal plus S bar ED. Am I right? Am I right or wrong? I am right or wrong?
So it's wrong.
It's wrong.
It's wrong.
It is not wrong. If I had written SCD, not bar, is equal to SCE plus SED, then I am wrong. If I write S bar, I am not wrong. Hello. What is this S bar doing then? It is adding the two displacements, also taking the directions into consideration. So if you take if you take those as vectors, that is, you are adding the magnitude along with the direction, then what I am writing is correct. If I am only adding the magnitude, I am wrong. Got it?
Yes, sir.
Hello. Now the question is, you know how to add the magnitudes. 10 plus 10 is 20. But how to add the magnitudes with the direction? So there is a different mathematics for that. There is a different mathematics for that. You will learn a lot more mathematics. So whatever mathematics you have learned is just the beginning. Very beginning. So you are going to learn much more mathematics. So you are going to learn one more type of mathematical addition called as vector addition. I will teach you. But in this class, you just have to appreciate that there is a concept called vector addition. Hello?
Yes.
Got it? So you are going to add the vectors, another 6 minutes. You are going to add the vectors, means you are going to add the two physical quantities which has got magnitude and direction, and they can be added together. Okay, so I just use the symbols here. So the plus sign here means vector addition. Got it? Hello? Now you see, now how to add the vectors along with the direction, magnitude with direction. It is not a very big problem. The Almighty has solved the problem for us. The Almighty has solved the problem for us. Sum of the interior angles of a triangle, how much is it?
180 degrees.
180 degrees. See, the Almighty gave this, because otherwise, see, if you draw different triangles and if the interior angles were different, then you would not have solved many problems. And the ratio of the circumference of a circle to its diameter is always equal to 22/7. The Almighty's gift. So here also there is a wonderful thing that has happened. What is it? Now you see, in this case, if you see these vectors SCE bar and SED bar and SCD bar, or in terms of geometry, see, S bar is specifying the displacement. CE bar is specifying a vector. Now here CE bar and SCE bar are one and the same, right? Now CE bar could have been velocity. ED bar could have been velocity in some other context. In some other context, these lines are representing some other vectors, force vector, acceleration vector. But in this context, these lines are representing displacement. So I am writing displacement. Got it? So CE bar is a geometrical line, basically. Now you see this line, CE, ED and CD, they are forming a triangle. So for us, if you want to add CE bar and ED bar, what is the sum of CE bar, SCE bar and SED bar? That is, if I add the two vectors, SCE bar and SED bar, if I want to add these two vectors, what is the resultant vector? Don't have to worry. Just represents SCE bar and SED bar by the two vector lines CE bar and ED bar. And then you take the tail of from the point C, you draw a vector 2D, and that is the sum total of this. So what I mean is, you see, if SCE bar is representing displacement vector of 10 units in the direction C to E, and ED is representing another vector whose magnitude is 10 units from E towards D, then the net displacement is from C to D with certain units. How much is that? Now, if this line, if I have drawn a 5 centimeter line, CD, and 5 centimeter is representing 10 units, and ED is another 5 centimeters which is representing 10 units, and this line CE, if it is 18 units, assume, then its magnitude is 18 units. Correct? So you just have to represent the vectors by the two sides of a triangle. The third side taken in opposite order gives you the sum total, the vectorial sum total of the two vectors, both in terms of magnitude and direction. Did you understand? Now that's precisely what I have written here. Please read it.
Thank you.
Thank you. The triangle law of vector addition states that if the two vectors are represented by the sides of a triangle taken in order means like this and like this. You got it?
Yes.
Then the third side is taken, then the resultant is the sum of the vectors given by the triangle on the third side in the reverse direction. See, if I drawn the vector from D to C, then it is the same order. Since I am drawing it from C to D, it is the reverse order. of direction and magnitude. In physics, the two vectors are said to be of same kind. So, in physics, physical quantities that get specified by specifying both its magnitude and direction and also obey the triangle law of vector addition are called vectors. So, how will you add the two vectors? So, there is a vector. Say there is velocity 10 meters per second towards north. Velocity 10 meters per second towards north. So, you represent it by a line 10 centimeters per second towards north. Okay. So, you represent it like this. So, supposing you see, you draw like this. This is north, south, east and west. So, 10 meters per second north. So, 10 meters per second north. So, I will represent it by this line. Right? Then, another car is moving at 10 meters per second east. Then, you will represent it. So, 10 meters per second east. It's another car. So, these are two velocity vectors. Assume that this is one velocity vector. This is another velocity vector. Now, for some reason, I want to add these two vectors. How will I add these two vectors? So what I will do, I will take this vector and I will bring this vector and keep it here. So this is V1 bar and this is V2 bar. I wanted to add these two vectors. That is, I wanted to form V1 bar plus V2 bar. So what is V1 bar plus V2 bar here? Complete the triangle. See, now supposing this line is 5 centimeters and this line is 5 centimeters. Then I will draw a line here. So this represents what? V1 bar plus V2 bar. Now measure its length. Its length will be equal to 5 root 2 units. So what is the sum total of these two velocities? 5 into root 2 times. So if you measure its length, that length will be equal to 5 root 2 centimeters. 5 root 2 centimeters, each centimeter was 2 meters per second. So this gives you 5 into root 2 into 2. That is 10 root 2 meters per second will be the resultant velocity. Did you get it? Yes. So life is simple, jingalala, because it fits into the triangle. The vectors to be added and their resultant will fit into a triangle. This is nature was provided us, and therefore this is how the vector addition is done using triangle law of vectors. Is that clear? Now the last slide I'll just show you, and I'll just tell you it's a very simple slide. So here you see in this diagram that this object is being pulled by two strings. So there is a string here and there is a string here. So my fingers are pulling it. Right? At an instant of time t, I am applying the pull. The pull is nothing but the two forces. And you see, I can apply some magnitude here and some magnitude here. It need not be equal. So the magnitude of force I am applying here is Fb. And the magnitude of force I am applying here is Fa. Got it? And the direction in which I am applying is towards B. So I am using a unit vector B cap. And here I am using a unit vector A cap. And now these two forces are applied at some time instant t. So at the same time instant, what happens to this? What happens to this at that instant of time? At that instant of time, what happens? What happens? Hey, imagine, man, if two things are pulling it like this, what happens to that object? At that instant. At that instant, what happens to that?
It experiences the force.
Pardon? It experiences the combined force. Combined effect of the two forces. Got it? See, this body will neither move towards this nor move towards this. Got it? Yes. It will experience the combined effect. Or nothing but you just have to vectorially add these two forces. Got it? Hello, you have to vectorially add these two forces. Are you able to get the concept of addition here?
Yes, sir.
So how will you add it vectorially here?
Triangle.
How will you make a triangle?
Join
A and
B.
Join A and B. Okay, fine. Good. You have some idea. Now, quickly I will show you how these two are joined. Okay. There are two ways of joining and doing. Now you can see here. See here, now look at this diagram. Please look at this diagram. So what I have done here, this FA bar was as it is. This FB bar, I am putting it here, the tail and tip. And I am completing the triangle. Can you see here?
Yes, sir.
So I get the resultant or the combined effect of these two is along this direction, both in terms of magnitude and direction. Got it?
Yes.
Hello?
Yes, sir.
Now there is another way of doing it. What is another way of doing it? This force is acting at this point, this force is also acting at this point, and then I am completing this parallelogram. Can you see? I have completed this parallelogram.
Yes, sir.
Right? And now I am drawing a diagonal from O to M. This diagonal represents both the resultant vector both in terms of magnitude and direction. Did you get it?
Yes, sir.
So this is called as parallelogram law of vector addition. Both are same, similar, but slightly different. Okay, fine. Any questions?
No, sir.
Right. I hope I made justice to all of you. Right? Okay. So here it is. Okay. So I will make this video, send it to all of you, go through it. If you still have any questions, you can pose the questions to me or even suggest, some ways of making this better. I'll be thankful to you. Thanks for attending. Bye.